is a calculation of the velocity squared divided by the radius. In other words, two variables affect G-force on the racetrack: speed and the sharpness of the turn. First, speed. On a flat track, if a car attempts a turn at 200 miles an hour, insufficient traction would cause the car to slide off the track. But at speedways like Talladega, the turns are banked at angles as high as 33 degrees. This banking allows centripetal force to help pull the car towards the center of the track and roughly doubles the effective weight on the tires. This increases traction so cars can go faster, which increases the G's in the turn. Next, radius. The distance from the focus of the turn to the curve. The shorter the radius, the sharper the turn, increasing G-force. Speeds through the turns at Bristol average more than 80 miles an hour slower than at Talladega. But drivers can actually experience more G-force at Bristol. This is because Bristol has tighter turns, with radii averaging only 249 feet. That's over 77% shorter than Talladega. As a NASCAR driver banks a turn, his body can experience up to 3 G's of acceleration, which means the average driver weighing 160 pounds feels like he weighs 480 pounds. When a driver races through a turn, the inner ear registers extra G's in the outward direction of the curve, while the eyes interpret the normal downward force of gravity. These conflicting messages can result in dizziness and disorientation. But like a fighter pilot, a NASCAR driver's training enables him to utilize a technique called vestibular suppression. Their brains ignore these mixed signals, and they can continue driving. At Bristol, drivers can sustain up to 3 G's, lasting roughly 5 seconds in each turn. That means, over the course of the race, they feel like they weigh 3 times their body weight for over 80 minutes. For ESPN Sports Science, I'm John Brinkus.